Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey everyone, welcome to a brand new episode of the Clear to Send podcast. I am your co-host, Roel Dionisio, alongside your other co-host, Francois. How are you doing, Francois?
Hey, good. How are you?
I'm good. I think I'm finally coming up for air after being completely busy since January, and I think you have too.
Yes, it's been crazy. The beginning of the year has been crazy for, I guess, both of us. So it feels like we haven't done this forever, right?
Yeah, that's what it feels like to me. And you guys can tell if you've been counting how many episodes we've released this year. We've skipped a few just because it's been difficult to get a well-planned episode out in time if we are to stick to a weekly schedule. And we'd rather not rush things, right? So we are now back. I'm actually sitting where I usually record, and I feel like I haven't sat here all year long, which is kind of crazy to think about. But that's also because I set up a desk upstairs. I record in the garage, but we're back. So we're going to talk about this episode came about when I started optimizing another network and took a look at the logs to identify why devices just weren't connecting to the Wi-Fi network. And it was because of client balancing. And so we thought this episode would be about client balancing, but we're going to change it around a bit and talk about optimizing, just have a discussion about optimizing a Wi-Fi network for the devices, right? Because whenever I talk to people, I always tell them that the devices ultimately decide what they want to connect to, right? Would you agree, Francois?
Yes. When it comes to how to connect, when to roam, who to roam to, who to connect to, they pretty much decide what they want to do. And depending on, the Wi-Fi driver, depending on the devices, they might not take the same decision. So you might have different behaviors depending on the client devices that you're using on your network.
Exactly. So the infrastructure, when it tries to make a decision for the client, I think really as far as which AP to join and how to roam, I think a lot of that's still decided upon the device, and the infrastructure will try to tell the device, but it still depends if that device has certain protocols enabled on that device, whether it's supported, and that's where our challenge lies, right? Especially in an environment that has multiple devices, where you're not just having one single type of device, but maybe you've got laptops and mobile devices that are connected both to the Wi-Fi network. And so when it comes to optimizing, I think that's where beyond the coverage and the capacity, but other optimization tips and tricks that we run into, not really tricks, but things that we've run into in an environment. What do we do to try to make that a better experience for the users and the devices they're using?
Yeah, and I think it's important to mention at this point that vendors, they've also acknowledged the fact that the client device is taking a lot of decisions. So they've tried on their own as well to develop some proprietary protocol to kind of influence the client devices to take the decision that they think is the best. And sometimes those little techniques can also produce like a bad user experience, or the client device might not really react in a good way to those protocols, because they're not like standard per se. It's like just different techniques that vendors use to do different things, and it might work with some clients and it might not work with other clients. So That's why sometimes we're experiencing what you experienced the other day with your customer, where you have some devices that don't perform as well as what we would expect.
Yeah, and I was at this location where devices sometimes just drop off Wi-Fi or it's slow. And so one of the first things I always look at, and this one was a Meraki network, was I look for client balancing because I know how client balancing looks like on a Meraki network and what that can do to a client. And when I was walking to a device, there weren't many people there. These were desktop computers; they're not wired, and it's Windows, a Windows based PC. I noticed someone didn't lock their computer, and there was no one there. And I said, "Well, that's a perfect time for me to analyze this connection here."
Did you buy a Bitcoin with the credit card?
Yeah, install a Bitcoin client on it and start mining. The first thing I noticed immediately, because it was already on, it's logged in, is that it was not connected to Wi-Fi, right? So the first thing I did was get the MAC address, and then I looked at the event log in Meraki to see what was going on. And I knew I had not made any changes, and plus I only had read-only rights to this organization, so they have to make the change for me. But client balancing was already enabled. But by looking at the MAC address, I could see that this specific device kept being rejected. The association kept being rejected due to client balancing. And when I look at that, and the way I did look at that is in the event log, you can actually filter the messages down to association rejections due to client balancing. There's a specific filter for that. And I look at how often it's happening, right? And one of the things I look at too is it happening a lot, right? Because if these devices are static, they're underneath they can view, they see the signal of a particular AP, right? Because they're not moving. The power was static, the channels, and so they have a very restrictive view of the Wi-Fi network. And for a device that does not move to be rejected that many times, and I would say like multiple times a minute in a minute, then to me that client balancing needs to be turned off, or something needs to be redesigned, right? Because when I look at client balancing from Meraki's perspective, I believe the algorithm is just based on load. I don't know what else is involved there, but there are numbers to this load. I don't know. There's no documentation that I've found that what that number means. It could be a percentage. It could be just the algorithm, the output, the result of the algorithm, or it could be however many devices are on there, although I don't think it's devices. But what I kept seeing was the load of the particular AP that the client wanted to join was higher than a nearby AP, which could have a load of 0. And so it would reject the association in hopes that the client would be like, okay, I accept your rejection. I will go find another AP, which would just be a probe response from another AP, right? And so the reason why I don't like client balancing from the AP's point of view is because what if the client just keeps trying to associate to the same AP, but the AP just keeps saying reject, and so that's why I turn it off.
Yeah, and I think it's because like there's a reason why the client always tries to connect to that AP. It's because its Wi-Fi driver told him to connect to that AP. So if you disconnect him, his Wi-Fi driver is not going to change his decision if the device stays stationary. It's always going to go back to the same AP, and then you're going to have just like what you experienced, connect, reject, connect, reject, connect, reject. And that can create those behaviors where the client is not able to connect to the network. And I think just to give some background information on client balancing, I guess, what the APs are trying to do. You can correct me if I'm wrong, Roel, but I think the AP, they're trying to see, and they're trying to load balance the clients in between the APs to make sure that you have like a consistent amount of client devices connected throughout the APs. And you don't have like, 100 clients on one AP and then 10 clients on the adjacent AP.
Right, exactly.
And they're trying to load balance the clients.
Yeah, and I think maybe in a conference setting, that might be ideal, but when you're in an environment where they're stationary and they don't move around, you would then have to move your APs around to provide the adequate coverage and capacity, right? But you can only put so many APs in close proximity, right? Because even if you use directional antennas, if you put them too close, there's going to be some overlap. And so one of the things that I was looking at was, well, maybe it's saying to go connect to another, it's saying denied because it's hearing its neighbor AP maybe very strongly, right? Maybe the transmit power is too high, but maybe from the client's perspective, that signal might be too low, right? It could be maybe near neg 70. And then that could be its threshold, right? That could be its association threshold where, sure, maybe it does connect to that AP, but then over time it'll say, you know what? I'm hitting negative 70 and closer to negative 72. I'm going to start looking for another AP to join to. But then as it tries to do that, another AP can say, no, I'm going to reject your association because my load is higher than the load of another nearby AP. You should go connect. So there's this constant cycle of, like what you said, Francois, is like association, reject, go associate to another one. And then as it tries to reassociate to another AP, reject again. It's like constantly being rejected, even though it wants to go connect somewhere. But I know some people will start thinking like, well, then it needs to be designed for that environment, right? And that's true. There was a lot more than just some simple optimization that had to occur. But even when the load is low, right? And again, I don't know how to analyze Meraki's algorithm here. For example, one of the log messages said a load of 5 for the AP that this client was trying to connect to. The best AP load for another AP was 0. Like, does it really make sense to deny that association if the load is so low? Like, we would have...
You even had one with a load of 4.
Yeah.
And yeah.
Like that. So that part I don't understand. And whether that means like 4 clients or 4% utilization, like to me, that's still good enough to accept other clients. But...
So what do you do in this environment? Do you just disable the client load balancing feature?
Yeah, I disabled it completely. I didn't. Some of the Windows PCs did not like the rejection that much because they would just remain disconnected. They didn't automatically rejoin to the network. Yeah.
And that's a risk that you can face when you have these features enabled, is that the clients might try a couple of times to connect to the AP. And then if you get too many rejections, the client will just blacklist the SSID, which can be dangerous because it will not just blacklist the AP, it will just blacklist the SSID, so that you won't be able to connect, and you'll have to force on the client device. You'll have to force, either to, it's usually a restart of the Wi-Fi card. So you have to disable it and re-enable it if you want to kind of clear that blacklist. So it's not ideal. And you can create those issues if on some clients. I know that iOS does this.
Yeah.
So it's not ideal, obviously.
Yeah, and not many vendors will have documentation as detailed as Apple. And I think Apple just has that partnership with Cisco, so we know a lot more of how to optimize for iOS devices. But when you're dealing with maybe Android or Intel, some of that documentation is not as detailed, right? So this is where a lot of that testing comes into play, and a lot of troubleshooting and analysis to optimize a network for these types of devices. And so just in my opinion, I don't like client balancing from the infrastructure's point of view. I prefer to try to help use the infrastructure to kind of help those clients pick, manipulate where they would go, right? Rather than just straight up denying them of association. So obviously, if you've got way too many clients then connecting to a single AP, then maybe there is a capacity issue there, and you need to look into adding an additional AP with the right type of antenna.
So what if we really want to do load balancing? What are the options out there?
Yeah,
I can think of a couple.
Yeah, we've kind of had an episode on this. We don't really talk about it as load balancing, but we could use 802.11v to try to help move clients to another BSSID, right? I know we talked about 11K, so those two kind of go hand in hand.
Yeah, exactly. With 11v, what you can even do is you can do what they call unsolicited optimized roaming request. So it's the AP telling the client, you know what, your RSSI and rate are too low. You should move to this AP instead. Or it can say, you know, you could have the other way around where the client is like, oh, I want to come and connect to you. And then the AP says, sorry, my load is too high, but you should go over there instead. And that's an unsolicited request coming from the AP. And if the client device understands this, then it has like a next candidate to just go and connect to. And, you know, you can avoid having that type of the issues we talked about earlier. But in order for that to work, you need the client device to support 11v. And usually that's where we're having some challenges in the enterprise space, because you have either those devices that don't support it altogether, and then you have those devices that tell us that they support it, but that they never end up using it. So
there is our challenge. The key part, right, is having the devices come up to speed and supporting these protocols. And these protocols have been around for a long time. You would think that maybe sometime soon we'd have it working the way we think it should.
Yeah, seriously, when you look at these protocols in more details, you're like, man, that's like the solution to all of my problems. and they're not they're not like widely supported. But I have another way of doing load balancing.
Okay. Let's hear your secret.
About it's not a secret. It's not even from me. I've heard it from someone else. But what you can do is you can limit the number of associated clients per APs. Okay. But you can do it in a detailed way. So let's say you have like an auditorium where you've installed 3 access points, right? One like right at the entrance, and then 2 other ones more in the center of the auditorium. So as the people come in, they will tend to want to connect to the first one that's right there, you know, next to the door. But then what you can do is you can say, okay, I'm going to limit the number of associated clients to like 50, let's say, for this AP. And so you're going to have like the 50 first clients that are going to connect to that AP. And then when you have the 51st one that comes in, you just deny association to this guy, and then he connects to another one. That's the second one that's in the auditorium. Would that work?
I don't know. It's still a deny, but I guess if the person's in motion, the device would pick up a beacon from another AP, and then as that device roams closer to another AP, it would join. But you might
still have the same issue. Huh?
Yeah, if they weren't closer to the middle of the auditorium and they were outside, but trying to connect to that first AP, they would probably never join it, right? Because it's reached the maximum. And I've seen this in a conference where there was a single AP in the room and it hit the maximum client. There was a max client connect there, and my laptop wasn't connecting. But when I looked at the frames, it did say association denied because it had reached I can't remember. I think it
maximum
yeah, I think
association
I
number.
determined that the message indicated it there was max clients connected, but there was no other AP for me to connect to, so I just stayed offline.
Mm-hmm. Too bad.
Too bad. So sad.
Yeah. Yeah. So I mean, to me, the 11V and the unsolicited request is like the solution to that.
Yeah,
As
I
long
agree.
as you're, and actually, that's how they fixed in the Cisco controller. They kind of realized that they had an issue with clients blacklisting their SSID, especially iOS clients. So instead of sending association deny, they will instead send a 802.11v unsolicited request, and then the clients will just decide to just acknowledge it and take action and move to the recommended AP, or just discard it and just do something else about it.
Yeah, because having that list of APs is useful, right? Because then that way the scan time can be minimized, because if it knows that there's certain APs on certain channels, then the scan can be limited to just maybe those channels. And that kind of dives into the optimizing with DFS channels in mind, because before we had recorded this, Francois, we were talking about how clients scan differently, right? So even if you have or are using DFS channels, you may want to consider how many DFS channels are in one particular area. And if you have a client that comes in and needs to scan, it'll be delayed in joining some of those DFS enabled channels, right? Because of the way the client will scan for channels. It doesn't scan them from the lowest channel to the highest channel. And you talk about the one method that you knew about.
Yeah, so I actually got this from a document from Cisco Live, a presentation from Gerard Henry. He was explaining how the scanning works on iOS. First, he was saying that the scanning depends on your country, right? So if you set your country to I don't know, some countries that don't support, let's say channel 144, then it's not even going to scan for that channel. And then after that, he was telling that the scanning of the channels is not it's not linear, where you're just going to scan 1 2 3 1 2 3 4 5 up to 11 and then start at 36 all the way to 165. What happens is that the phone will actually scan unit 1 and then unit 2 and then unit 3, so it skips unit 2 extended, and then it scans the 2.4 channels, and it does this 5 times, and only after that it scans unit to extended. So if you have access point in unit to extended that you're trying to roam to, you can have somewhat of a delay, because you have to wait for all of the scanning to happen before you can even discover APs on channel 100 to 140. So if you have how you could just use that information is if you know that you need a fast roaming to a specific access point, because it's like the first one in a hallway, or sometimes you and I do a lot of warehouses, and sometimes you have like 2 warehouses stuck to one another, and sometimes you have this transition area, and you want the forklift to quickly roam to the new AP or the new area. It's better to make sure that specific AP is in a channel that can be discovered first, right? Yep. Unit 1 is like the best, because that's like the first set of channels that are scanned by the device. If you use one of the unit to extend it, you might see some delay in the connection, but that's very client specific. So what you might have to do is study the client behavior. So you might have to do some packet captures. The only challenge I see from our standpoint is, to really study that, you need to do packet capture on all channels pretty much. Right? So that can be a challenge for us. Even though, now with the, you can do that with the WLAN Pi and couple of USB hubs, and
you'll need a few of those devices,
a few adapters,
a couple of sidekicks. You'll need a NetAlly Etherscope. You'll need just all of them.
Well, Well, the issue, one day I've done that. And one day I did that. I did packet captures on different channels from different devices, and then I had so much trouble trying to sync everything back together with the same time, that I actually try not to do that. I
Try to
remember I
stick with
had like
one device.
I was doing like from a Sidekick, from AirCheck, from AirTool, and I didn't get the same time everywhere. So I was like, oh man. So it's actually easier to like how I would do it today is, with the new AirTool and the remote packet capture you can do from the WNPi, and the multiple packet capture you can do from the WNPi. I would probably do that, like a couple of WNPi with like, a few NICs connected to them on USB hubs, and then try to hope that I'm not missing any packets.
Yeah, because there is the
frames.
potential to miss some of those frames over the air, but at least in this case, you're still trying to analyze like that roaming behavior for the client, and what we're saying is in a condition where a device will need to roam, that's where you'll want the AP that device would first see should be maybe uni 1 channel, because it would start off at the scanning at the lowest channel.
Or if you can leverage 11K, and with 11K, it's pretty much, you'll get like a list of best APs to roam to. So the client, instead of scanning all of the channels, it now has like a limited set of channels to scan, and you can optimize the roaming delays quite a bit. The clients, it will just tell the AP, the client will tell the AP, okay, I need to roam. Can you just give me the list of APs I should roam to? And the AP will send, the best 6 candidates. So now instead of scanning, how many channels, many times, you can just scan whichever the one they are in the short list, and you can cut down the roaming time to quite a bit.
Yeah, that client would then send a reassociation request directly to that AP.
And something also that we don't think about very too often, but it's especially important when you do voice over IP. And Andrew McHale has talked about that quite a bit in his presentation as well. But the scanning is done while you're still connected to an AP. So the client would do like some off-channel scanning. So let's say the client is operating on channel 36. It will go off channel 36 to go to channel 40 to do a scan and try to discover APs. And then it will go back to channel 36 to maybe send some data traffic. And then it will do another off. So like that scanning can actually take quite a while, especially if you're like on a voice call, let's say.
Yeah.
Right. So, and then if you're mobile and you need to roam, you don't want the scanning to last 10 seconds, right? You want it to be like milliseconds, so you actually don't lose any voice packets, and it's like seamless to the application.
Yeah. So again, that's why we like 802.11k and V, but if it works on those devices, if it works as how we think it should work, again, and more analysis on the device that you're using. I wouldn't just trust it just because it says it supports 802.11k, V, and R and all those. Like, try to grab those frames over the air and see how it is using it, right? Like, is it, if the AP provides a list to the device, do you see the device scanning maybe just for the channels on the list, or for the APs on that list, or is it just trying to scan everything still all at once, right? Then that would mean it's not using 802.11 kV. It may support it, but it's not using it, like Francois said earlier.
And I've seen that with iOS sometimes. And doing that process, it's actually amazing to learn more about Wi-Fi, because every time I do it, I find out something new, and it forces you to go back in the standards and try to see which frames you're expecting, and if you're studying for different certifications, or if you just want to know how it really works, how the frames works, doing that work of validating if a device supports different amendments, it's actually a really good work to do to kind of study and get a better understanding of how Wi-Fi works. It's and you're gonna get surprised every time because client devices changes, the drivers changes, you update iOS, and all of a sudden it's not the same rules. So yeah, you're always surprised.
Yeah. So when it comes to designing, then like you can do like an auto channel feature, right? In Ekahau and have it pick the channels for you. And then you've got a nice heat map of, very low co-channel contention, but you still want to consider where channels are on the floor plan, especially for roaming, right? So that's how we tend to optimize for devices is we don't just put any channel anywhere just so we can get low co-channel interference, but we do think about like what you said, Francois, like you've dealt with automated guided vehicles, like that's going to be important for roaming and how quickly they can go to the next access point. So that's just something to consider as far as like optimizing for the device and not necessarily for your infrastructure, right?
And I guess talking about roaming, sorry to cut you, Roel, but talking about AGV and something I do with the AGV is I also adjust the roaming threshold on the client device, because sometimes that's something you can do. It's not always the case, right? You cannot do it on iOS, but on some devices, especially in the industrial environment, I mean, you and I have been working with like, barcode scanners and all of these type of things. And most of the time we can adjust the roaming threshold. So we can have a little bit of play in terms of, how sensitive we want the device to be. And when we want to trigger the roaming mechanism, when we want to trigger the scanning. And that's usually, something I do when I do the validation. I test these things, and then, I don't really have like a set value I use all the time, but I do some different testing. And in the given environment, given the APs the customer has and all of that, I try to find the best value for the environment. I don't want it to roam too much, but I don't want it to wait too much before roaming. That's kind of like what I look at. And I know I've done a survey before that, so I know my signal strength coming from different APs. I know my AP placement and all of that, and I try to assess, looking at that and looking at how fast the client roams. I try to assess, which roaming threshold is the best for the environment. And doing that exercise is actually quite nice as well.
Devices are the first thing I check anyways, and I still prefer the Android and even some of the Windows based scanners because of the flexibility they do give you in those settings, right? With iOS, there's nothing to set. It's just Wi-Fi is on or off. That's your only setting on iOS devices. But when I do look at the devices, I always check to make sure that whatever channels are being broadcasted by these APs, make sure those channels are also enabled on the device. I've been in many environments where they say they have coverage gaps, and I look at their environment, I'm like, you have a lot of APs. You sure you don't have any coverage gaps? And so what I'll see is they're using all the channels, right? DFS channels are using all of them, but on the scanners, maybe only Uni 1 and Uni 3 are enabled. And so I
see that too.
Yeah, I see that all the time. And then that's where I tell them, like, okay, enable them all, get an MDM so you don't have to touch every single scanner. Like, just push a profile and be good with that. And so always remember the device itself needs to, if you're dealing with like a non-Apple device for barcode scanners, like check those settings. There's going to be a lot of settings that probably aren't enabled by default.
Yeah, and I've seen the exact same thing. I think it's like a default config on these guys. So by default, it's not enabled. So if you don't check, you don't know, right? And you really have to go under the Wi-Fi setting advanced, just like 3 or 4 menus down.
Yeah.
And then you can see the channels. So like, I mean, people usually don't really think about that.
Yeah, I mean, they assume it works, right? If it connects to Wi-Fi initially, it must be working. And so that's what happens. And it's the same on the infrastructure side, right? People will deploy an access point and let the automatic stuff, the default settings take place and let it run. Like that's what happens. It happens. And I mean, that's why we're involved, and that's why we're here to help design and optimize and troubleshoot Wi-Fi networks.
That's why we're getting paid a lot of money. That's what you were going to say.
Wait, what? You get paid a lot of money? All right. The last thing I want to talk about, we're not going to talk about every single type of optimization here. Just some of the more common ones that we run into, but matching transmit power from the AP and the clients, right? Because certain clients can only have a max power level, and sometimes you get sticky clients, clients that are trying to transmit back to the AP at the highest modulation, but they're too far, so the AP can't demodulate the signal. What are your thoughts on matching transmit power, Francois? I
think it's yeah. I do it as well, but I think that it's I think here's historically speaking, when we're using like 11B and the early version of the protocol, I think we were using more power, and I think it was okay on both sides of the communications, and we're also using less complex modulation techniques.
Yeah,
which made the communications exactly, and made the communication a little bit more robust. And I don't know if you had the case, but sometimes I have customers that migrate from like 11B and they had like 3 access point, and then they migrate to 11N or AC and they have 20 access point, and then they complain. It's like, your new crap doesn't work. It used to work better with 11B or whatever. So I think that's something that we have to pay more attention nowadays. And something that's very tricky with that is that the maximum transmit power that's advertised by the device, like what is it? Because when the device connects to the Wi-Fi network, it will advertise its maximum transmit power, right?
But it will only give you
it will only give you one value. And it will tell you, for example, I support maximum, 14 dBm of transmit power. But if you actually start to look in details, you'll see that, that value might change depending on which channel you're using, which frequency band. Some devices will have different maximum transmit power, whether they're using unit 1, unit 2, unit 2 extended, unit 3. And sometimes you might have like 2-3 dB of difference, in between those bands. And on top of that, this is the maximum transmit power. It doesn't mean that it's always going to use it. Mobile devices, they'll tend to try to save battery life. So most likely they're not going to use their maximum transmit power all the time. If they're able to conserve a little bit of battery, I'm guessing that they're not going to use their maximum transmit power. Right?
Yeah, that's a good point. And whether or not that's been tested, like transmitted signals from a fully powered down to maybe a half power, or maybe less than half, right? Maybe 20% or less power, battery life is what I'm referring to. Like maybe then the actual power that the radio is using on that device is much less, right? Is that's what you're getting at?
And that's not even mentioning that some, devices like smartphone, for instance, they could also have like a negative gain on the antenna. So, most of the smartphone, they'll use this P5 design of antenna, and some of them have a negative gain, which means that even though they advertise the fact that they have like a maximum transmit power of 14 dBm, maybe with the negative gain, their the actual EIRP, will be like lower than that. Maybe it would be like 12 dBm or something like that. So I think we have to be careful. We definitely have to don't configure too much transmit power on the AP. But at the same time, you don't want to go too low either, because if you go too low, then you're going to provide a lower SNR to your clients, right? Yeah. So you still want to be able to provide the good SNR so they can actually, see a good signal and then be able to use good data rates. So you kind of have to try to find your balance.
Yeah, and I think that's why like open office type environments or very open space can be challenging if you've got a large space and you're using a lot of APs. Because we just said you don't want to broadcast too high, the transmit power too high on the AP. You also don't want to go too low, but then that would dictate how many APs you're going to deploy. But then you don't want to run into too much co-channel. There's just so much to think about, right?
yeah, it's always a balancing act. That's what Wi-Fi design is all about.
Yep. And
Right.
this is where a lot of testing is important. So I would always try to encourage when you're doing a project to consider the testing portion and test as much as possible, and not so much just blindly design based on requirements, because some of those, they may have the requirements, but can you meet those requirements specifically when roaming, for example? Are they going to meet those requirements when you've mounted certain APs in certain places or using the right antennas? So there's a lot of testing that's involved in, and mainly for the complicated environments, right? Not and it's mainly the warehouses where I find the most complicated, especially when this particular warehouse had low. It was like a large warehouse, but it's like very open space, so there wasn't a lot of racks, and if they did have racks, they weren't very high. And so instead of mounting APs up high with antennas, we actually have to bring them down lower, closer to the floor, but still use directional antennas in order to shape the signal down to where devices would be.
Mm-hmm.
So like that's all the different kinds of ways to optimize. And this all started with client balancing, as I was trying to talk to Francois on Slack about it, going, hey, what do you think about this? Look at this frame that I found. And then led to having this discussion in this podcast about maybe not so much client balancing, but optimizing for the device, with not by doing it from the infrastructure side of things, especially when devices aren't fully supporting all the protocols.
Yeah, I guess I didn't fully answer your question. Going back to the transfer power, what I like to do actually is to be a little bit conservative, I guess. So because of the negative gain and the fact that I'm not sure they will always use the maximum transfer power, if the phone advertised, let's say like 14 dBm, maybe I'll go down a little bit. Maybe I'll go down to like, 11 or 12 dBm on my APs to try to give me a little bit of margin. And then in my design, if I need a little bit more signal somewhere or whatever, I'll go up to 14. And then in my ORM, if I do use our ORM and configure, I'll just give it like a bracket of between 11 and 14, if you will.
And and as you're talking, I'm
like
pulling up some frame captures that I have, and I did find one for a reassociation request coming from a device, and it has a tag here for power capability, and it provides a minimum and a maximum, right? So the maximum is 21, but the minimum is -7. So that could be maybe the ERP, the antenna, right? That you were mentioning.
Oh, no, it might also be the power minimum. That's very low power though. Minimum 7. Or
-7, yeah.
Yeah, that's pretty low.
Huh? To the point where it's a whisper. It's whispering. It's saying, "Hey, I want to reassociate."
Yeah. So, and do you know on which channel you got this?
This one was on channel 48.
Okay. Yeah. So I think if you want to get all the information, you need to do this work or the profiler or whatever, but you have to do it on the different sub band. Unit 1, Unit 2, Unit 2 extend in Unit 3 to kind of see the difference.
Yeah.
So you could do that. You could do profiler on different bands.
So it looks like we'll need to test iOS devices. I wish I had scanners, but I don't have any scanner. Or I guess we could use an Android. A lot of scanners are Android based, so can you try to use a Samsung? We'll see.
Yeah. We can try different devices and see what they advertise.
Lots of testing, lots of analysis. Let us know what you guys think. What are these some of the things that we talked about? Is that something you guys consider in your environments? What other things do you consider the most? Because everyone's in different environments, so there's different settings and designs that that we all run into. But let us know. This is going to be, I think, episode 259. So cleartosend.net/259, where you'll find the show notes. I'll include a screenshot of client balancing from Meraki along with the frame capture that says association denied, and we can continue the discussion there.
Sounds good. And if you guys have a little tips and tricks and stuff you do to optimize, I'll be happy to hear that too. Yeah. We always learn from other people too.
Yeah, exactly. It's really good to hear from other people and their environments and the kind of issues they're running into and their solutions, and even showing down in Slack like what they're running into. I think it's really cool to see what others are running into.
I agree.
All right, guys. I want to thank you guys for listening, and we'll see you guys on the next episode. Bye, guys.
See you guys. Have a good week. Bye-bye.